Hello, so let us try to look at the questions from a second exam. So the first one, the angle of the triangles here, ABC and the ratio of 8 to 3 to 4. So as soon as you see the word ratio, then what you can do is that instead of writing 8, 3, and 4, you can write down 8x plus 3x plus 4x. And then since we are looking at the angles, interior angles of the triangle, that will add up to 180. Now, then here we can add them up. We will realize that becomes 15x is equal to 180. And then when you divide by 15 on each side, x will be equal to 12. And, 12 seems to be the answer. No, not really, because we have to read the question till the end. It says, what is the measure of the smallest angle? You see, the smallest angle is the one that has 3 in it. In other words, 3x. So 3x will be our smallest angle. So 3 times 12, because since the value of x is 12, right? So we end up getting 36 is our final answer, which is choice 3. High five. That's right, Isabel. Now let's look at number 2. So we have these two angles, 70 and 50. What is the measure of angle LKN? LKN, you see, this angle that we see is the exterior angle of the triangle. Then how do you figure out the measure of the exterior angle? Yes, measure of the exterior angle is sum of the two remote angles here. So if I were to call this one as x, x is simply 70 plus 50. What is 70 plus 50? That's right, that's equal to 120. And choice 2 becomes our answer, therefore. Let us move on to number 3. Lines are parallel here. That means we have to think about corresponding angles, alternate interior angles, and then things of that sort. So here we have CHF is 20. That's given right over here. And then DIG is 60. What is HEI? HEI. So let's call that as X. But if you look at this one carefully, you would have realized that we have triangular shape going on right around here. Right? Now, then if due to the vertical angles being congruent, we can say this is 60 and this is equal to 20. Then in other words, when you add up all three of them, they'll be equal to x. So what is x? X equals from 180, we're going to subtract 60 and 20. Now, then here, 180 minus 80, we get 100, which is choice 3 becomes our answer. All right, let's look at number 4. We have two parallel lines, and this is angle 1 and this is angle 2. But wait a minute, what do you realize? Did you realize angle 1 has corresponding as angle to this one, angle right next to angle 2? Then you would have realized that when you combine this angle and angle 2 together, that would have been straight line, which in other words becomes 180 degrees. So therefore, angle 1 and angle 2, when you combine them together, it would have been 180. You see, angle 1 goes up here, adding to angle 2. All right, then we're just going to write them up. So 4x plus 14 plus 8x plus 10 should be equal to 180. Now when you combine them together, we get 12x plus 24 is equal to 180. So subtracting 24 from each side, we get 12x is equal to 156. So if you divide by 12, then what do you get? X equals, that's right, 13. So 13 becomes our answer, choice 3 once again. Oh, wait a minute. Choice 3, this one was choice 2. All right. Number 5, a transversal intersects two lines. Which condition, now we have transversal and then we want to make sure that two lines are parallel. How do you do that? Yes, I understand that vertical angles are congruent, but that doesn't prove that if the lines are parallel. We have to show that alternate interior angles are congruent, choice 2. See, the reason why number 3 is wrong is corresponding angles are not supplementary, not necessarily. Corresponding angles, in fact, are congruent. And then same side interior angles are, in fact, not complementary, but it would have been supplementary. So these are wrong. So that's not it. Let's look at number 6. The degree measures of the angles are represented by these. Find the value of x. So what are we going to do? We're going to add them up and set it equal to 180. X plus 3x plus 5x minus 54 has to be equal to 180. Now here we get 9x minus 54 is equal to 180. Now adding 54 to both sides, we get 9x is equal to 234. Now let's try to divide by 9. What is x equal to? X equals to 20, 26. So the answer is 26. Yes, as my daughter mentioned just now, we end up using 180 for many things here. Let's look at number 7. In the diagram below, these two lines are parallel. And we see the right angle over here, that's equal to 90. Now, angle 1 is 63. Now, as soon as you realize that angle 1 is 63, given that this is a parallel line, what else do you realize? That's right, this angle is also 63 because they are alternate interior angles. You see, sometimes you can look at the alternate interior angles by writing down the z. In this case, it will be backwards z, and then those are same angles. Now, how about angle 2? In fact, angle 2, since I don't know what it is, let me call that as x. But once again, when we have 3 angles in a triangle, when you add up 3 angles in a triangle, what will that be equal to once again? That's right, 180. Haha, it's almost like automatic answer at this point. But be careful, we have to realize the relationships first. So we get 180, and you're going to subtract 90, along with 63. That's how we can figure out the value of x. Here then 180 minus, when you combine them together, we get 153. Now 180 minus 153, yes, it becomes 27. So 27 degrees will be our answer. Alright, let's look at number 8. Using compass and straight edge, so let me take out the compass and straight edge. So here, compass and straight edge. Alright. Now construct an equilateral triangle. So how are we going to construct the equilateral triangle? First, I have to move the corner of the compass on one side and open this one up to mark the side, the length of AB. Now then, using that, I'm gonna make an arc over here because I don't know where the intersection would have been, and that spread is supposed to be the same thing as spread of AB, the length of AB. Now bring the compass to the other side, and then without changing the spread of the angle, I made the arc. Now then, as you can see, there's an intersection over there. Then using a straight edge, you can draw the line. There it goes. That's supposed to be an equilateral triangle. Alright, great. Let's look at number 9. Using a compass and straight edge, once again, right over here, compass, and a straight edge. They want us to copy the angle. So how are you going to copy the angle? First, draw a line segment. And then, we can bring this one up. and open it up and make an arc from the vertex of the angle. Now, without changing the spread of the angle, I want you to copy the arc on the newly drawn line segment. And then go back, oops, and bring back the compass, and then I want you to measure the spread from this intersection to this intersection. Okay, right about there. And without changing anything, notice that this point has to be at the intersection. And draw the arc. Alright, now, then all you have to do is connect the line segment with that intersection. There it goes. I copied the angle from here to over here. Number 10, using only a compass and a straight edge. So once again, I'm going to take out a compass and a straight edge. Please, for your quarter exam, bring your own compass and straight edge. I'm sure it will be very helpful. Construct a perpendicular bisector. Now, and then perpendicular bisector, how am I going to do it? Let me just, first, what you can do is you can put the compass in the one corner and open it up. Make sure you go more than halfway. So maybe I guess this might be more than halfway. And I want you to draw the arc up and down like this. And without changing the spread of the compass, bring your compass to point B and then draw that line. Then notice that you will see the intersections over here. Now, okay, and then we can just draw the line up and down. Then here we'll end up getting perpendicular bisector. And they told us that, and label it C, so we just have to label this one as C. This one is C. Hey, high five. All right. Let's look at the next question, number 11. This is another exterior angle question. We have to remember, measure of the exterior angle is sum of the two non-adjacent angles. Now, then how are we going to write up the equation? We're going to say 6x plus 20 is equal to here, x plus 40. Adding that with 4x minus 5. Now, then let us try to combine the right side. What is x plus 4x? It becomes 5x, isn't it? Now, how about 40 minus 5? That's 35. Now, on the other side, we have 6x plus 20. So now what we can do is we can subtract 5x from both sides. Then we get x plus 20 is equal to 35. Now what are we going to do? Subtract 20 from each side to have the x by itself. Then here we get x is equal to 15. Now, is my answer 15? No, not really, because I want you to look at the question here. I want you to find the measure of angle QPT. QPT, in fact, that angle is what we're looking for, isn't it? So, therefore, we're going to plug in 15 in place of x because x is equal to 15. So let's try to figure this one out. 6 times 15 plus 20. What is 6 times 15? That's 90. Plus 20, which is equal to 110. So 110 becomes our final answer. Alright, number 12. Once again, we're going to use the compass and a ruler. Here is my compass. Here's my ruler. Whenever I use this, it's quite amazing that we can use this one with the computer. Kind of funny. All right. Let's try to do the angle bisectors here. How are we going to do it? First, bring your compass to the angle. I'm going to do angle C first and open it up. Just, it doesn't have to be a particular distance, just, a little bit. And then draw an arc. And bring your compass. And then put the compass at the one corner, one intersection between the arc and the triangle. And you can draw an arc right over here. Then make sure that passes through the midpoint. And put the compass on the other side once again and draw the other arc. Now then you will realize the intersection here. All you have to do is connect the vertex of the triangle and the intersection. There it goes. So that's one angle bisector. Now, another thing would have been from point angle A. So let's bring the pointy a sharp point to vertex A, and then draw an arc and go to the intersection and draw an arc over here. Go to the intersection and draw another arc. Now then, just like before, all we have to do is try to connect the vertex and then the intersection. All right, so that's how we can answer this question. Number 13. So this is the last question here that we have. Using compass and straight edge. So here it goes once again, compass and a straight edge. Now perpendicular line. How do you construct a perpendicular line from here? First, I want you to bring your compass to the point P and open up your compass more than the opposite side. That passes opposite side, and draw an arc. After you have drawn the arc, I want you to go back and then make sure that your compass is open more than halfway. I don't know, around here, I guess. And draw another arc. And do the same thing with another intersection right over here. All right. Now, what are we going to do? Use your ruler to connect them together. All right. So that would be the perpendicular line from point P. I know there's a little bit off here, but I guess we can consider that as a human error. How about the parallel lines? How do you construct a parallel line that passes through the line P? Then what I'm going to do is this. First, I'm going to draw a line that passes through point P. And the next one that I have to do is I just have to copy the angle here that you see over there. So first, draw the arc and then copy the arc. And then measure the spread. And then draw the arc. And I want you to go to the intersection. And then copy the arc. Now then all you have to do is simply connect the point P and then the intersection. And voila, we're done. We constructed the parallel lines. I guess that's about it. And I'll see you later. Bye-bye.